Saxon Math 7-6. This is a repeat, not a repeat, but a second look at lesson 116. The topic is unit multipliers. Joel, I'm going to try explaining this in a different way than I did last time. I'm going to try and give you a little bit of a different context. I'm going to start by talking about a different operation in math that carries some similarities to what we're trying to learn new this time, okay? So I'm going to try and get us onto some familiar ground of a similar process, remind you of how that works, and then we'll take a look at how this new process is kind of like that. All right, let's say that we're adding fractions. Let's pick some simple fractions to add. Let's say we want to add 2/3 and 5/12. Okay, now let's just remember our process for doing that. In order to add fractions, the denominators have to match. We figure out what the matching fraction should be by finding the least common multiple of 3 and 12. That's 12, right? 3 goes into 12. So we don't have to change this one, we only have to change that one. So in the way I make my notes, I would rewrite the 5/12 like that. Okay, that part is not important to our conversation. That's just the context of the problem. Now this is the part that is going to relate to what we want to talk about. Okay, we look at our 2/3. We're starting with a 3. We know that we want to end up with a 12, right? So we look at our starting place and our ending place, and we figure out what's it going to take to get us there. And we know that we have to multiply by a fraction that's equal to 1. Do you remember when I used to draw these? This is supposed to look like a 1. And it's a reminder that this fraction, whatever we're using to adjust this fraction, top and bottom, it has to be equal to 1. If we multiply by anything that is not equal to 1, then we're changing the original number and it's not the same problem anymore. If this is equal to 1, then our fraction will stay in balance because multiplying anything by 1 doesn't change it in value, right? It changes the shape of it, but it doesn't change the value of it. That's exactly, oh my gosh, put that thought in your brain, okay? So this fraction has to equal 1, and we determine what it should be by looking here, right? This, to get that, we have to multiply it by 4. We use our times tables to help us get from here to here. All right, so let me put an equal sign there. So now we have figured out the bottom, and then the top is easy, and we just multiply through, okay? This process of multiplying by 1 and figuring out what goes in here by comparing beginning to ending, that is crucial to what I want to tell you next. Okay, and then just, because I couldn't stand it if I didn't, there's the sum. That's not important. Okay, that's getting our headspace in the right place. Now let's talk about unit multipliers. Let's use the example that you and I were talking about on the phone, and I'm going to change it ever so slightly, but it's the same idea. You are working on a project in your backyard. Heaven help me, I can't imagine what you would need 4 feet of chain for. But let's say you need 4 feet of chain. Okay, or I'm sorry, 4 yards of chain is what you need. And when you get to Home Depot, you find out that no, the chain you want, they only sell by the foot. Okay? So you have to figure out how much chain you need if you're ordering it in feet instead of yards, okay? It's just like this, where you have to change something, all right? You have to change the shape of it without changing the value of it, right? The amount of chain that you need is staying exactly the same. You just have to order it in a different unit. So the shape of your requirement is going to change, but the value, the amount of chain you actually want, is exactly the same. That's not changing at all, okay? Similar to this. So, just like that, we have to multiply this number by a fraction that's equal to 1. We don't want to change the value, we only want to change the shape from yards to feet. okay? Now here we were multiplying by a fraction, and so let's make this a fraction too, right? And we almost always have to do this because our original number usually comes as a whole number, so we always put it as in a fraction shape by just putting a 1 underneath it, all right? So now it looks just like this, right? And we don't know what number we want to end up with. We know what unit we want to end up with. So that's kind of the same, but a little bit different. But it's the same idea. Our goal is to change the shape of something without changing its value. We're going to multiply it by 1. Now, how do we know what goes in here? Before, we figured it out using simple times tables. This is different. Because we're changing units, we're going to look at some fractions, again, that are equal to 1, but that combine the different units that we're interested in. This time we're interested in yards and feet. So we have to think, pretend that's a dotted. I prefer for that to be a dotted line so you can see they're equals. We have to come up with 2 fractions that link yards to feet that are equal to 1. So the first one that jumps into my head is that 3 feet are equal to 1 yard. Does that make sense? That's a basic fact that you know. These 2 things are of equal value. So even though the numbers are different, as long as I write the unit on there, I've created something that's equal top and bottom. Maybe you can hear guys are rebuilding our fence today and they're taking everything down, so they have big old drills out there and they're just cutting through everything to cart away the old panels. It's a little noisy, but it's okay. Okay, so this is one way to write a relationship between feet and yards that's equal to 1. The other thing we can do is flip it upside down. We can write 1 yard equals 3 feet. Okay, so what we're doing is we've created 2 fractions. Their fancy name is unit multipliers. We've created 2 fractions that are equal to 1, because 3 feet equals 1 yard and 1 yard equals 3 feet, right? It's 2 ways of saying the same thing, but both of these are equal, top and bottom, equal value, different shape. And we're going to use one of these to multiply here, just like we multiplied this to change its shape. We're going to use one of these here to change its shape from yards into feet. Now, how do we know which one we should use for this problem? Here is the magical piece of information. We want to choose the version of this that has our starting unit on the bottom denominator, if you will, but bottom's easier to remember. Okay, the starting unit on the bottom, our starting unit is yards, so we want this one because it's got yards on the bottom. If our starting unit was feet and we were trying to go into yards, then we would choose this one. So, but we simply look here and then we choose the one that has the same unit on the bottom. Here we used our timetables, right? And we said 3 times what equals 12. Here we use this simple set of facts. We have to know these relationships. We have to build 2 versions of the right multiplier. And then we choose the one with our starting unit on the bottom. So I copy that into our box. 3 feet equals 1 yard. Okay, so now I'm multiplying my original number by a fraction equal to 1 in order to change the shape of my original amount. Now, what the heck are we doing? We're writing words in our math problem. There's no words up here. That, I think, is what blows everyone's mind at first, is what in the heck are we doing? How are we doing math with words? Well, we can do it. It's not that hard. Words obey the same rule that numbers do, and so what we can do is cancel these 2 yards, right? We're multiplying these together, and we can cancel anything top to bottom. So we can cancel yards to yards. Does that make sense? Just like we could cancel numbers if we were multiplying a set of fractions or something. We can cancel any unit top to bottom. And spoilers, that's why we wanted the starting unit on the bottom, because we want to be able to cancel out the starting unit. And now we're left with the unit that we want our answer to be, right? Home Depot, feet, yay. So this shows us that we have done our work properly. When we've got our ending unit, our desired unit is the one that's left after we cancel, then we know we did it, we're good. Now all we have to do is gather up the numbers and simplify those. So here's my equal sign. 4 times 3 are the numbers left in the numerator, and on the bottom, 1 times 1. Okay, there, I'm just rewriting the problem without the word so we can see it a little more clearly, which means we need 12 feet of chain at the Home Depot. I'm breathing and imagining my sound waves carrying these ideas into your ears and into your brain, and it sticking in the right part of your head. Now, I know that you're probably thinking, this is dumb. 4 yards, I know automatically is 12 feet. You just multiply it by 3. Why are we doing this whole crazy thing? I know, I understand. That's what I thought at first too when I first came to understand John's method. But I promise you, this is going to get more complicated. Here we only multiplied by 1 unit multiplier. And I think I mentioned this to you on the phone yesterday. Even Caleb, who's only in the next book, is already doing problems where we use 6 unit multipliers. We use 6 different fractions like this to make all the adjustments we need to get from beginning to ending. So it's going to get really, really complicated, okay? And you're going to need to have a process for writing it out because there's no way you're going to be able to do 6 of these in your head, I promise you. Okay, so I know it's easy now. Thank your lucky stars and use this as an opportunity to really understand what we're doing. Let's try another one. I'm going to go to the book now and pick out a problem. I'm going to do, this is a problem from lesson 116. It's a regular problem set problem that you do for your homework. This is 6A. And I'm going to do it a little, there's an A and a B, but I'm going to change it a little bit and just do it as a regular problem. They ask you separate questions, but that's okay. Okay, so here's the deal. We've got 8 gallons of what? Eight gallons of milk. Your mom bought extra. You know, COVID, got to stock up. And she wants to freeze it. But in order to freeze it, you're going to get some quart bottles that your mom has in the basement. And you're going to pour these 8 gallons of milk into quart bottles because the quart bottles are better in the freezer. Okay, this is plastic and this is glass. I'm just spitballing madly here to give you a story. Stories help our brains understand what's happening when the numbers make us feel confused. The stories help us. So you've got 8 plastic milk gallons sitting on your kitchen counter that your mom bought from Costco. And she told you to go down to the basement and get enough glass quart jars for all this milk. How do you know how many to get? Well, let's figure it out. We know that we can make this into a fraction over 1, and we're going to multiply this by a fraction that's equal to 1, because we're not changing the amount of milk, we're just changing the way that we measure it, right? So this is going to be a fraction, and we want to be able to relate quarts to gallons. Okay, some of these relationships you may already know. Some of them you may need some help for. In the book very often gives you hints, and I'll tell you that the problem that I chose for your final exam has a relationship that's probably not familiar to you, and I just give you the information too. So let me tell you what the book writes. 1 gallon equals 4 quarts. If you can't remember these easily, I suggest you write them on the inside cover of your homework notebook. And spoilers, you can always Google them, okay? So that's never a problem. You can always get the answer to one of these relationships you don't understand. But we learned that in 1 gallon, it equals 4 quarts. So I'm gonna draw my multipliers down here. And I like to draw them in like a rounded box so I can tell that this is something special. And I put a dotted line. Last time I accidentally drew a solid line. But I put a dotted line, and that's to remind me that I don't need both of these. I'm only gonna choose one. Okay, so I'm just gonna copy it. 1 gallon equals 4 quarts, and 4 quarts equals 1 gallon. I usually leave the S off just because that just adds confusion if sometimes you use the S and sometimes you don't. You don't need it to be plural. Just leave the S off. Okay? And again, even though this seems really dumb, you write it both ways, just flipping it. You write both versions of it because you want to use the one that has starting units on the bottom. We'll get faster at this. When we go further along, we'll kind of streamline this process to make less writing, but for right now, I want you to write it out exactly the way I'm doing it, okay? And P.S., I should have told you this at the beginning. If you didn't, go get paper and pencil right now and copy down this problem as far as I am. Pause me, catch up to where I am, and then go on with me. You should be writing as we work because it makes your brain work better. The movement of your hand helps your brain. It releases different chemicals in your brain. So we want to choose. Okay, so now I'm assuming that you're working with me. You've got your pencil and you're ready to fill in with me. We want to choose the version of this that has the starting units on the bottom. Our starting units are gallons. Gallons are over here. Okay? It doesn't matter which order you write these in. It doesn't matter which one goes on the, which one's first or which one's the bottom. As long as you get both versions, that's all you need. Okay? So this one happens to be on the right. The last one happened to be on the left. It could be different if you wrote them down in a different order. None of that matters at all. Okay, this is the one we want because it's got gallons at the bottom and gallons is our starting unit. So I'm going to write here 4 quarts equals 1 gallon. Okay? And now we look and see and make sure that our units cancel. Okay, gallons, gallons. This one I wrote out, this one I abbreviated. That's fine. It doesn't matter. Gallons cancel, top and bottom. We're left with quarts, and that's good news because what we want is quarts. So now we simply multiply. Here's the 8. I'll just circle them. I won't rewrite them like I did last time. I have 8 times 4 on the top, and I have just 1s on the bottom. So that means you need to get 32 of those glass quart bottles that are down in your basement and pour all the milk in. And if you don't spill, you'll end up with 32 full quarts of milk to go in your freezer. That should last you for a few days anyway, right? Okay, so there's another example. I'm going to do one more before we move on. I have to find another one. Okay. I'm going to use a fresh piece of paper. And I'm going to make up my own problem. We have 45 centimeters of ribbon we need to buy at the store. I guess I'm in the mood to shop. I haven't done much since COVID. But when you get to the store, you find that it's only sold in meters. So we have to convert from centimeters to meters. Okay, that's fine. We'll do it. Now, you may notice we're in the metric system. Over here, we were using yards and feet, and then quarts and gallons. Those are both what we call the English system. And now we're switching to the metric system. Guess what? It doesn't matter. It works exactly the same. It's no big deal. So we're going to do it exactly the same. We're going to put this in a fraction over 1, and we're going to multiply it by another fraction that is equal to 1 that's going to change the shape of it, but not the value. And in particular, we want to change the unit, all right? So we have to find our 2 unit multipliers, our 2 fractions that relate the starting unit to the ending unit. And here it's centimeters and meters. And so we have to stop and think, what do we know about centimeters and meters? Which one's bigger? Okay, I know that this is the way my brain likes to think it through. Which one's bigger? 1 meter. A meter's bigger, so I put that one equal to 1 on the top. And then I figure out how many centimeters are in a meter, 100, because the word cent means 100, like century or centurion, the Roman soldiers that worked in ranks of 100. Okay, so that's the way I often think of the first one. I figure out which unit's bigger, I write that one on top with a 1, and then I figure out how many of the little ones are inside of it, and I get 1 meter equals 100 centimeters, and then I just write it the other way. Okay, now I have 2 unit multipliers to choose from. Only one of them is going to go into my spot. So I have to pick which is the right one. What's the rule again? Oh yeah, starting unit on the bottom. So what's my starting unit? Centimeters. Okay, so here, again, it's on the left this time, but that doesn't matter. It's just a function of which one I wrote. It doesn't matter. All that matters is that you choose starting unit on the bottom and then copy that one into the box. 1 meter equals 100 centimeters. Okay? Sometimes my writing doesn't fit in my box here. That's okay. It can splurt out. It's not a big deal. Okay, I'm ready to multiply. First, I check to make sure it cancels. Centimeters cancel to centimeters, top and bottom. Yay, it worked out perfectly. That leaves me with meters, which is exactly what I want. Make sure when you do these problems, you do it exactly like I'm doing it. Cross out, circle, circle. That shows us that you canceled properly and your ending unit is right. Sometimes people will accidentally write the wrong fraction here. They might accidentally just copy that one in. This is where you catch your mistake, is when you go to cancel. Because if you wrote this one up here, centimeters would be on the top, and when you went to cancel, it wouldn't work. Okay? All right, so now we've canceled our units. It all works out perfectly, and now we just gather up our numbers. I'm going to ignore the ones. There's a 45 and there's a 100. So 45 over 100 is how many meters we need. We could write that as 0.45, or we could divide it by 5 top and bottom, and that would be what? 9 over 20. Either one of those answers would be perfectly fine for me. 45 over 100, I would ask you to simplify if we were on the test. All right, but both of these answers here, I just converted it easily into decimals because it's over 100. It was so easy. And then the other way is I divided top and bottom by 5 to simplify the fraction. Okay, Joel, we have now worked through this. I've given you a different way to think about it by showing you how what we're doing is actually quite similar to this process. I want you to try the practice problems I want you to try lesson 116 practice, and I want you not to do the every others. I want you to do A through G inclusive. That means all of them, right? I know that's more problems than usual, but I want to make sure that your brain gets a chance to practice it before you move on to something else so that it really sticks in your head. They shouldn't take that long. The first 3 are just talking about unit multipliers, and then the second 3 are actually doing the conversion. And then after you get a chance to do those, I want you to radio into me, whether you email me yourself, getting my email address from Micah. I don't think Daniel does. Daniel and I always texted. You can text me, get my phone number from your mom. You can email me directly, or you can just tell your mom and she can message me however she wants to let me know. But tell me how this is going. Give me a score. 1 means I'm still lost. 5 means totally get it. 3 means you're wobbly. You sort of get it, but not really. So then 4 would be pretty good. And then 2 would be, you might not feel completely lost, but you still just don't understand. Okay, 1 and 2 are kind of the same. They're bad news. So let me know where you're sitting in terms of that score. Okay, I'll talk to you soon. Bye.